Hello everyone, this is Mr. Phil, your Saiyugan teacher, and for this video podcast, we will be discussing about scientific notation. So if you're interested, watch this out. Alright, so we are going to be talking about scientific notation. So what is scientific notation? It is a way how to write a very big or very small number in a condensed form, which makes everything more practical and easier for us to compare data. Alright, so there are rules in writing scientific notation, and we'll go to each one of them, and then we'll have practice so that we'll be able to really understand what is scientific notation. So let's start. Okay, first, the scientific notation are written in two parts. One is just the digits, okay? That is called your mantissa, wherein it is composed of one whole number from 1 to 9, followed by a decimal point, and then the number of significant figures, okay, in that number, okay? And then followed by a multiplication with 10 to a power of number of a decimal point that puts the decimal point where it should be. So basically, it follows this format. You have M, which is your mantissa, again, a number that is from a real number from numbers 1 to 9, followed by a decimal point and then the significant figure, times 10 raised to a certain number n of how many times you have moved your decimal point. If you're moving the decimal point from the right to the left, then you're using a positive exponent, and if you're moving from the left to the right, you're using a negative exponent. Rule number 2 and 3. If the given number is greater than 1 and multiples of 10, then the decimal point has to move to the left and the power of 10 will be positive. Example, let's have this. 8,000 will be 8 times 10. Let's make this 8,100. 81,000 will be 8.1 times. How many times do we move the decimal point? It's from here. 1, 2, 3, 4. 8.1 times 10 raised to 4. Okay, I'll make this bigger. Okay, raised to 4. Alright? And then let's have this one. If the number is smaller than 1 means the form of decimal numbers, then the decimal point has to move to the right and the power of 10 will be negative. Example, here, scientific notation for 0.0080 will be 8.0, alright? Because a whole number here, followed by the significant figure next, which is 0, times 10, raised to how many times did we move it? We moved it 1, 2, 3 times. I'll make this bigger. Now you see it's negative 3. Okay? So I will remove this because we don't need as much. So it will become like this. Let's have more examples. This. Okay, let's put it so that we can clear things out. How do we write this thing? Okay, first count how many significant figures are there. So you need this 2 only. So I write the mantissa, which is a whole number, followed by a decimal point and a significant figure, times 10 raised to how many times I moved it. So if you come to think of it, a decimal point is from here. All right, and then we will move this decimal point how many times? 3, 6, 9, 12, 15, 16. I moved it 16 times. We have to delete all of these ones, okay? They will now transform to the times 10 raised to 16. So that is how you write that number down. Okay. Now, what about this number? How do we write this? So first count what are the significant figures here. It's the last 3 digits, 1, 2, and 0. Again, the mantissa, one whole number followed by decimal point, and then the significant figures 2 and 0. How many times did I move the decimal point? 3, 6, 9, 10. It's negative 10. Okay, because I moved the decimal point from the left to the right, so I'm using negative. So if the number that you're using is more than 1, then you're using a positive exponent, and if you are dealing with a small number less than 1, you're using a negative exponent. Okay? I have more examples. Let's say I have this number. All right, first find how many digits you have to put in your mantissa. You have the 15 there, 1, and then followed by a decimal point because you only need one whole number, 5 times 10 raised to, how many times did you move the decimal point? So you basically have the decimal point at the far end. From the right, we're moving it to the left, so it's positive. 3, 6, 9, 12, 13. So we moved it 13 times. What if it's 15, 0, 0, 1, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, what if it's like this? First, know what are the significant figures in here. So we have to write this in our mantissa. We start with 1.5001 times 10 raised to, how many times did we move the decimal point? We have 3, 6, 9, 12, 13, still 13. So we moved it 13 times. All right? What if we'll have a smaller number? Okay, so what do we put in mantissa? It's the significant figures, the 500. So it's going to be 5.00 times 10 raised to, how many times did we move the decimal point? 1, 2, 3, 4, 5, 6, 7, 3, 6, 9, 10. Now, what about the last two, mister? Well, you only count how many times you have moved your decimal point. So in here, it's going to be written this way, and it has to be negative, okay? Because we moved the decimal point from the left to the right, or the number is smaller than 1. Remember, if the number is smaller than 1, we use a negative exponent. If the number is bigger than 1, we use a positive exponent, all right? Let's have one last and try this. Okay, so how are we going to be writing this? Try to guess first. I'll give you a few seconds to think. All right, so mantissa, know what you should put in the mantissa. These 6 numbers. So it's going to be, the mantissa has only one whole number, okay, decimal point. How many times we're going to move it, the significant figures, times 10 raised to, we know it's smaller than 1, so it should be negative. How many times did we move the decimal point? 3, 6, 9, 12, 13. We moved it 13 times. All right, I kind of love 13. Okay. So that is how you transform a very big or very small number into its concise form, or the scientific notation. Okay, so in this video podcast, we've discussed what is scientific notation and what are the rules in writing scientific notation. If you have any questions, please put in our Google Classroom, and see you again on the next podcast.